Hi, thank you for tuning in. Sorry about that. I accidentally clicked off of it too late. There we go. Okay, so thank you for tuning in. This is the poster presentation of the semester long research that a group that I'm a part of did. This is the optimization of an M63 medium for the growth of Escherichia coli, and this was conducted via response surface. So why are we optimizing the M63 medium for the growth of this bacteria? Well, E. coli, it's used in a lot of different industries, pharmaceutical and biotech industries, will exploit the recombinant properties of E. coli in order to produce proteins that are useful for research or as medication, etc. In order to get to these high yields and useful amounts of the protein of interest, we would need to have the highest growth possible of the E. coli themselves. So, therefore, you could optimize growth conditions to potentially reach that highest amount of biomass or the greatest yield. The objective for the experiment was, of course, to optimize this M63 medium recipe for the highest amount of the biomass of the bacteria. The methods used would be the shake flask method, as well as Minitab statistical software. We're using this computer programming instead of doing the traditional screening methods throughout the whole time of the experiment in order to streamline it, and as well as to apply statistics and all these statistical analyses to help design the response surfaces as well as the fractional factorial to really hone in on which nutrients were actually affecting the growth the most. Methods, so we prepared the medium, the nutrients, and the E. coli inoculum. You make shake flask. We had 13 shake flasks, and then of course we added the nutrients. We had 5 nutrients. We had casamino acids, which are going to be the hydrolyzed proteins, specifically casein from milk. We also had magnesium sulfate, ferrous sulfate, the M63 medium base, which was a 1X, and thymine. Then our carbon source was glucose. Then you incubate. Then we would record the absorbance at 600. That's just the thickness of the culture or the medium when light is going through it using the spectrophotometer. You're going to get some scattering of that light. If it's very thick, then that's a higher absorbance. That means more cells are suspended. Then you would use this data to design a fractional factorial. This is very useful for optimization since the fractional factorial will report which of the factors that you're trying to test actually had the greatest impact or the greatest determining effect on the output or the Y variable you're looking for. Specifically, in our case, it's the biomass, the amount of biomass. So from the fractional factorial, we're actually going to be prioritizing the optimization of which nutrients that we need to actually start playing around with the levels over the others. Because again, this is an industrial sense. You don't want to waste reagent. Okay, now comes in our response surface. This is going to be, again, designed in Minitab, and you're going to be using the increments that you set in a range, and then the Minitab just designs what levels go into each flask, and then from those readings you get the absorbance, you get these contour plots, and then you just follow the contour and continuously and hopefully get a higher amount of biomass, and then of course scale up into the bioreactor once you get the optimized formula. Okay, so from the fractional factorial, the data there provided that we tested all the 5 nutrients and we designed that experiment. The fractional factorial revealed that glucose and casamino acids were the greatest determining factors on E. coli biomass. This just means, for lack of better words, focus on these 2 ingredients because they determine the amount of biomass. versus focusing on all of the nutrients. Just focus on these two. With that being said, we did our response surfaces. We had to do 5 of them. So you have cas amino acids on the y, glucose on the x-axis, and you're plotting absorbances. On the contour map, the light green is the lowest absorbance. On the first time we were doing it, it was like a 0.8 or less than 0.8, and then our highest absorbance, which is shown by a darker green, that was greater than 2.4. So this contour plot, you would follow the dark green area, placing it around this top left corner, and from that dark green area, that's where the levels of glucose and cas amino acid have to be at in order to get that highest growth / highest absorbance. After successive response surfaces, we get to our 5th one. And again, we have cas amino acids on the y and glucose levels on the x, plotting absorbances. However, this time we have the dark green being absorbance greater than 6. On the contour plot itself, we had an increase in the absorbance from our initial one about 2.4 to now greater than 6 after 5 response surfaces. We were able to climb the contour plot into the area that had the greatest absorbance / the greatest biomass based off of the increments of glucose and cas amino acids. Interestingly, in the response surface 5 contour, we do have our peak within the graph. We've achieved the peak. So this will actually give us the optimized amounts of glucose and cas amino acids that would potentially lead to the greatest amount of growth. So if let's clean up that dot. So let's see. So I'm going to the dark area, the darkest green area here, and I'm going to make a dot right in the middle as best as I can. And I'm going to just extrapolate down. From this dot here, at the peak from this contour map, we see that we would need about 4.6 ml of cas amino acids and about 2.3 ml of glucose for that optimized medium for the highest amount of biomass. And then, of course, the scale up. So we scaled up the culture into a bioreactor, and we got an increase in total growth from about 0.9 to 2.41. 2.41 was the total growth of the bioreactor. This is, again, a 2-liter bioreactor. When we took a sample of that, we got 2.41 as the total growth, and that is just to show that compared to the minimal N63 medium that wasn't optimized, we do get an increased growth of almost more than double. Yeah, more than double the amount of total growth when we use our optimized medium. All right, that's about it.